The Arctic. Centered around the geographical North Pole is a world of exceptional beauty and harshness. The cold world, the cold sphere, the cryosphere. The Arctic cryosphere holds the key to understanding what will happen in a warming world. To the ocean currents, to the sea level around the planet, to the patterns of wind and precipitation. And the Arctic cryosphere is changing. We are beyond the point of possibility of denial or theoretical suspicions. No matter whether we observe the ice sheet on Greenland, the sea ice or the frozen land, the facts, the events taking place right now, in our time, tell us that the cryosphere is changing. Moreover, the changes are much more dramatic and abrupt than anyone has ever imagined.
In terms of how worried we should be, yes, we should be worried. We have to observe what's going on, we have to model what could happen, and we have to pay very, very close attention to it. The risk is so great that we have to be very careful.
This film is about a major scientific project, the Swipa project, that monitors this development. Swipa's basic task is to evaluate current scientific information on the changes in the Arctic cryosphere and what these changes mean for the people of the Arctic and the inhabitants of the world. The Arctic cryosphere is divided into three major components: the Greenland ice sheet, the sea ice, and the terrestrial cryosphere, meaning the ice on rivers and lakes, the snow and the frozen ground. So let us have the facts, as they look here in the autumn of 2009. In a warming world, the Arctic has experienced an average rise in temperature since 1960 of approximately 2 degrees Celsius, significantly higher than the world average. This rise in temperature has had dramatic impacts on the different parts of the cryosphere. The Arctic Ocean is covered for most of the year with ice formed from frozen seawater. The extent and thickness of the ice vary over the season, building up to a maximum during the long Arctic winter, melting to a minimum during the short Arctic summer. Over the last 30 years, both winter and summer ice have undergone rapid change. The extent of the summer ice has been reduced by 30%. Remarkably, the past 5 years, 2005 to 2009, have had the 5 lowest annual ice extents since satellite measurements began in 1979. Various observations also show a reduction of Arctic sea ice thickness during the last decades. The sharp decline in the extent of sea ice leads the scientists to a rather dramatic forecast.
We can see that from newer studies now that it points more that an ice-free Arctic could already, or almost ice-free Arctic could already be reached in 2040.
An almost ice-free Arctic Ocean during summer will not only lead to significant changes in animal life, it will also mean easier access to oil, gas and other raw materials in the Arctic, as well as the possibility of considerably shorter sea routes north of Russia and America. The Greenland ice sheet is the second largest piece of ice in the world, after the Antarctic ice sheet. Just to get an impression of the size, if the entire ice sheet melts, global sea level would rise by about 7 meters. Every year the ice sheet receives approximately 600 gigatons of snow on its surface. And when the ice sheet was in balance, the ice sheet delivered an equal amount to the surrounding sea, by melting from the margins and from the carving of icebergs. Those days are over, The glaciers in Greenland are literally spitting icebergs out at an accelerating rate.
Every year the Greenland ice sheet is becoming smaller. The loss of mass, especially from ice discharge, exceeds the amount of snow that Greenland ice sheet receives every year, and the trend is increasing. We're simply losing more and more ice every year.
The Arctic terrestrial landscape is undergoing widespread change. There are changes in vegetation, the tree line is moving north, and the terrestrial components of the cryosphere, snow cover, freshwater ice, and the permafrost are changing rapidly.
We know that in Canada, snow over the last 60 years or so has been decreasing. In Eurasia, it's been increasing until about 30 years ago, in the late 1980s, then something happened suddenly, and instead of increasing, the snow started to decrease. The period of snow is also changing, so the date on which the snow leaves the landscape, when it thaws, that is becoming earlier and earlier.
Vast areas of land in the Arctic are permanently frozen. The frozen state goes on year after year, and the depth may be up to several hundred meters. Permafrost temperatures have increased during the last 20 to 30 years, and along the margins of the permafrost zone, permafrost has been lost. Arctic ice caps and mountain glaciers cover an area of over 420,000 square kilometers. This is over 55% of the total global mountain glacier and ice cap area. Shrinkage of mountain glaciers and ice caps is substantial. In the Russian Arctic, for example, mountain glaciers have lost between 17 and 30% of their surface area. And in some cases, even up to 50% of a glacier has disappeared.
The general trend for circumpolar Arctic is accelerating of melting for all types of glaciers, from ice caps to mountain glaciers.
The ice cover of rivers and lakes is also reacting to warming.
We see actually accelerating rates of change, mostly in terms of the timing of events. So earlier breakups, previous we had 100-year analyses, but over time we're seeing actually the breakup is advancing more and more in the springtime. And with that we've seen some changes in severity, so things like ice jam floods that have a lot of implications, but less so on that, more so on the dates and the actual dates of the timing of events.
Overall, the 21st century to date is characterized by an increased level of river discharge of freshwater to the Arctic Ocean. All parts of the cryosphere have a high degree of variability. The amounts and distribution of ice and snow can shift dramatically from year to year. However, long-term monitoring reveals the general trend. The Greenland ice sheet is losing mass. The sea ice is retreating rapidly. The permafrost is warming and thawing at the margins. The glaciers and ice caps are shrinking, and the rivers of the Arctic are pouring fresh water into the sea. However, the most astonishing fact is the rate at which these changes are occurring.
There was some sort of dramatic effect in the 1980s, the mid-80s to late 80s, when we saw big changes. And after that date, we see an acceleration of already rapid processes. And this goes right across many different features of the environment: the snow, the permafrost, the ice on this lake behind me, tree line advances, many different things. They're not just changing gradually, as they have done in the past, they are accelerating.